Previously on Rich Rebuilds.
All right. Yeah, grab the shaft. Right on with the shaft. Got it. Swing over. Swing over, grab it.
And John's getting ambitious. He's gonna put it right in there.
Yes, I am.
Yeah.
It actually looks pretty damn good, Steven.
I was reading the comments from the last video, and a lot of people were frustrated and upset that we didn't decide to go with a belt drive. And the reason why we went with the chain drive is because A, it's much simpler, it's more cost effective. This chain wasn't very expensive. This sprocket was literally $17 and the rear sprocket was like 50 or 60 or so. So it's a really easy and a quick setup, you know, for a relatively inexperienced person to convert gas motorcycle into an electric swap using chains. Not only that, but we're not really sure how the drivability with this motor is going to be just yet, because it's used to having this big honking, maybe 40 horsepower V-twin engine along with the transmission that, you know, did a lot of the torque multiplication for it. This will be direct drive, but we're not really sure where we want to be in terms of top speed just yet. The sprockets allow us adjustability for low-end grunt or top-end power, and we could actually adjust the sprocket size accordingly. This is like I want to say like a 12 or 13 tooth sprocket, and if we wanted to go bigger here, we could with relatively simply. Same thing with the rear. If we want a bigger rear sprocket, we get a higher top speed. Smaller front sprocket, we also get more torque. What's been racking around my brain all night is that this will be loud. It's going to sound like a chainsaw. It's going to sound like the Cyber Quad did. This is a Harley Davidson and it should make some noise. And safety-wise, motorcycles probably should make some noise anyways. I mean, I think so. I mean, you ride bikes. I mean, I ride bikes too. Having a belt drive instead of the chain drive, it'll make it a very stealth bike. We'll probably get killed on a lot faster because no one's gonna hear us coming at all. And also with the belt drive with the sprockets, it's a lot more difficult to get the adjustability front and rear. Like for example, on this bike, there's only one size rear sprocket, and for the front, there's really only one or two side sprockets. Your adjustability is very limited, and this is all for the sake of being quiet. Now here's the thing, in the comment section also, I said—
Oh, you really went in there.
I really went in there. They said it was gonna be a very easy thing to do. I should bring this sprocket, this belt drive sprocket that I got off the transmission, to a machinist, and they could do this in 15 minutes. All right, I'm gonna screenshot that comment right now. So when I pulled this off the transmission, we have a little problem on our hands here. A, there's no keyway. This is a spline drive, and it's also far too big.
Is that like a toothpick in a volcano?
That's a hot dog on a hallway.
Is that what that is?
What we're gonna do, Steven, we're actually going to find a machinist that can do this for us in 15 minutes, because he said, the random commenter said it can be done. This is the problem we're facing too with this project. We don't want to just have this project linger for too long either, because we have other really exciting stuff in the pipeline. And this is one of the things, going from the chain drive, which is, this is all set already, to the belt, that's gonna set us back a bit, all because we listened to the comment section, but we love our people. And now adapting this is gonna take, I think, more than 15 minutes.
In other good news here,
the batteries have come in. 3 of the 4 batteries that will go in this Void. We went with a 72 volt system. It's a total of 4 batteries, totaling 100 amp hours. The zero battery pack that goes in most zero motorcycles is about a little bit under 100 amp hours in some cases. This should give the bike some serious punch in order for it to accelerate as quickly as it can.
there's no wiring to add to these. This is a plug and play solution. We want to show you a simplified version of how to do this.
You can build your own batteries for sure. But again, if you want to get this done in the time frame we allotted for it, we don't want to do that. This is going to take a lot longer. These are already sealed and waterproof, and now it's just a matter of mounting the batteries in the frame. Oh, also, we have to wrap the batteries because they're blue, and it doesn't go with the theme.
After recutting the tank here, this is what it's looking like. We've put in 3 of the 4 battery packs. We're testing out what their fitment is. What do you think of those?
Can I get a few words? I'm just cutting with no guard, don't mind me. There'll be a 4th battery in there. It can be a total of 100 amp hours, which should be good in terms of range. We're figuring out whether or not 72 volts is gonna be enough. I think it will be, considering how much weight was removed from this motorcycle. I think it should move along pretty good. But again, still figuring that part out. It looks like we're gonna be going back with the belt drive. It'd be nice to have a smaller drive sprocket again, but We'll see how it turns out. It might be a similar ride to the engine that it replaces, just a lot more torque. A lot more torque and a lot quieter. No more shifting, just one gear and you just crank it and go.
So do we need to go deeper?
Go a lot deeper, yeah. Unfortunately, there isn't enough depth. This is a 4.5-inch cutting wheel and it can't get in there. So we need a bigger wheel, or we need to buy Harley Davidson special tool. It's probably like 1.5 inch nut. That's also an extension.
It probably costs as much as the battery.
Seriously, so I'm like, no, it's not gonna happen. I'm gonna cut this thing off. And normally I'd be like, okay, we shouldn't cut this, but it's fine because this nut, it won't make much of a difference on this because that's not how it's gonna be mounted. We have to end up machining it to get it to fit on that shaft of the motor.
That'd be a better way to do it.
There's gotta be a better way to do this.
It really is, but
There's no better way.
right. I mean, for what we have for tools here and now, I mean,
Nope.
oh. So close. So far away. So we've got everything to bare metal so that we can weld on our exoskeleton.
Oh, cool. So battery box out? Oh, for 3 or 4?
All 4.
Did that fit in the frame somewhere?
I made a mock-up so we can play around and see what will fit nicely in here. So the other option B, once again, we only have 3 of the 4 packs. We made this box, and we're trying to figure out if we can run them all in parallel with each other and kind of have it built up right in front of the motor itself. Looks like it'll be able to clear both the rear brake and the non-existent clutch, which we may put something else there for the time being. I'll tell you more about that much later on. This could actually do the trick and it'd be a lot cleaner, a lot easier, and then even just for wiring and testing of the modules. So motor is in. Now we'll see. Huh, looks like there's some room for activities. That is about where the tank will rest. Obviously, these will not be here, go under there. The only key aspect now will be to take the exoskeleton Ducati framing that we're going to do and bring it further out. If we do run it in parallel like this, it's out about 2.5 inches. Might have to slightly modify what we've got for our design. All in all, it's looking pretty good.
Can we slide it back more or no?
What's that?
The motor, can we slide the motor back? Now that tab is cut for the reverse switch, the brake switch, it can go back more. Look.
Well, you know,
You drew something, you cut some tubes with the tape. I think it looks pretty good.
put some cardboard and some, yeah.
It looks good.
The only issue with that is now that we've decided ultimately to change the form factor with the battery box. So what we're going to need to do is find a way to have this come out. So the part that's here for the motor is fine. We could solve this in 2 moves. This piece, if we notch this so that pulls out, and then if we put a bracing piece that's up here that pulls these tubes further outwards.
Yep.
That way, we'll be able to get the surface area needed to fill in with the battery box that this will be able to fit, and this will be able to pull out. These we can do the path of least resistance where we won't have to notch and do all the different types of tubes.
So you want to have this kind of, how's it, so this is going to come out at an angle slightly, then go in?
So this one, if we do it from like a side profile, this will be 2 different pieces. One that comes out like this, and then it comes back inwards.
Oh, I see what you're saying. Okay.
And then this will just have a piece that pulls out of here.
Yep.
And then comes down. So that way we can continue with this very minimal, very Ducati strike off of a design. This looks kind of fugly in cardboard and yellow tape.
I think it looks cool as hell.
Okay, I'm glad you're excited.
I'm really excited. I almost want to leave this exposed and just have it rust, like Harleys do. Just kidding.
Or if enough oil gets on it, it won't rust at all.
We're gonna rub these in with the oil. Actually, the second you weld it to the frame, the oil in the frame
Seep out and just honestly, it's just so that's where we're at, and that hides and makes it not everything looks so awkward of just battery box, motor, controllers hidden. Yeah, it's coming along.
That should be the default location. I'll go round, round, round.
Oh look, more grinding. Can you believe it?
Shocking. We took a poll and people love to see grinding more than anything else.
Is that true?
This whole build, the whole thing.
That's what they want to see more than
What do you
anything.
love? No, banter? No. Grinding? Yes.
There you have it, shiny metal to grind. So well done. The bottom bracket kind of bows in here, so this is to have an extension to build this up for the motor, and because the battery box is going to be quite wide, so it's going to be like this, and this is going to come around, connect into here to go right around your rear brake, and then I'll have another tube opposite of that angle to come into here, and then follow everything you saw in cardboard. So
I like it.
now we're just making it a reality, since we can't ride on cardboard.
Steven, talk to me.
All right, so we're making the angle iron for our frame for the battery box. I've already cut these two down there, and then unfortunately, the other ones, well, there's no other way to cut it except to put it in your vise, take this, and
The blade's gotten a little small. I think he's not thinking a lot today.
well, I mean, it's definitely gotten its use, but there's better ways to do this.
There are.
But
But why do it that way? This is way more fun.
precarious is the word we were looking for. And then it drops. There you have it.
You're just watching the sparks fly next to the paint cans.
Isn't it something? Weld that all up nice, and that'll fit all 4 of our battery modules in there. The master cylinder for the brake over here that we'll probably have to relocate. But this tray, that's not in the way. I want to make another bracket part that's going to be there so that it's level to match to the back. Using the motorcycle lift from Ranger. Thanks, Ranger. This will be easier. Well, we've got a blend between metal and cardboard right now.
I think it looks pretty good. More than pretty good.
It's one way to put a design in there to kind of give the aesthetic.
That looks like a rib cage. Waiting on that sprocket. That should have taken 15 minutes. Still waiting on that. So
It's been 15 days.
yeah, it's been a while. Yeah, thank you, kind stranger. But yeah, let's keep plugging away at it. Gotta weld some more bars in, and then the other side is the hardest part where you have to attempt to make a removable cage,
Right.
which is even more challenging. So
This side will look pretty and neat. Everything will be welded in, shut in place. And the other side will have all the accessibility to get, you take your tank off to get to your controller, pull out your batteries, pull out your motor, in case you need to, if anything goes faulty. But this side, purely aesthetic. All right, it's some ridiculously late hour, but here we have probably our final resting place for the design of the exoskeleton that kind of cradles in the motor and the batteries. This pleases you.
this pleases me because I always thought that it needed something there because what most people do is they just stick a motor and a battery into a motorcycle, and they rub their hands together and say, okay, we're all set here. Like look at it. So Google search right now, electric motorcycle conversion. That's what I would dare say all of them do. Even for the minimalistic cafe racers, what they'll do is they'll cut part of the frame and they'll just have this massive box of a battery just sticking down to about here. Just kind of wasted space. It's like a big square. So this actually makes it look good. Like there's stuff to look at. And we talked about it earlier. I was like, the second we pulled that engine out,
You were bothered.
I was like, this doesn't look good. But some people think it looks good. It's like, oh, well, it's minimalistic. There's no more complicated engine in there.
No, I mean, a V-twin is, let's be honest, albeit slow.
It's slow.
It's a pretty good looking engine.
It's also leaking oil right now.
Yeah, it's again, once it's a reminder, it's still leaking.
I don't understand.
It's a Harley.
So this looks infinitely better. It looks like we actually put thought into the design. And as you said, it's very Ducati-esque.
It's a style that I've always appreciated. The only change I'm still kind of wrestling with, to add another type of piece here, you know, like a build out here or another one here, tessellate it more and overcomplicate it.
Yeah, but then
as
I
time
feel like
goes
once
on.
you add one, you're going to want to add another.
Right. There's a lot of ways to go about it.
Yep, and that's why you'll see most bike manufacturers like Zero or even the Harley Davidson Livewire, they don't leave just the battery and motor there.
Right.
Like you tell that there's actually a stylistic sense around the battery pack to make it look more desirable and not just like, hey, it's an EV, it has to be ugly, like the Nissan Leaf.
I hated the first iterations of Zeros, and then the latest one that they did.
Yes.
Again, they went with the naked bike theme, and it looks awesome.
They hired a styling team. It's like they hired a designer.
They did.
They did. You could tell they did.
Yeah.
It looks great. And then we also hired a designer here, which is Steven. There you go. And it looks, honestly, that's pretty much spot on. You know, we have to make do with what we have because this is almost like a fantasy and a suggestion because when we work with the actual metal, we'll realize in some cases we can't put things where we want. Like we want to have this tube a little bit further up, but we can't. When you turn the bike all the way to the right, it would crush it in some certain sense.
Yeah.
So it just wouldn't make much sense.
Yeah, this is why people hate architects that just do things on paper and then be like, oh, you can't do it that way.
Yeah, right. We can't be rigid here because, you know, there's a lot to work with.
Because again, from the beginning, we were assuming that this could be a flat plane, but then where the motor and the batteries were kind of bulking it out, it's like, okay. And it looks better this way.
Way better that way.
The final design is actually, I like that.
I think once this is all black or whatever color, some uniform color, it's going to look really good.
Yeah.
And as you can see, I took off the front lights. The front lights are over here. These don't make any sense now. This was back in the day, way back in 1997 when lights sucked because there was a center light right in the middle. Remember the center light? It was a 7-inch center light and they needed this accessory lights and turn signals because they didn't really know about LEDs or like how to light things up really well then. Yeah. And now there's a single 7-inch LED light that casts way more light than these halogens ever could.
Right.
So I'll be getting rid of these, going to a center light right in the middle. And not even having to, do you need turn signals? Use your hands. Boom, boom. Left, right. Yeah.
You don't need these ambers. No one needs that ever.
No one should have ambers ever. No one should have amber lights. And the other thing is we actually removed all the gauges in the cluster as well. All except for the speedometer. We have 2 here and 2 here. We're debating what we want to do for this one. I think for these 4, I may have the individual voltages of each battery. And then for this might be an information display.
You found a really nice one as well that had the battery charge on it.
I had a battery charge readout on it. It had how many amps you're using, watt hours, and also run time as well. So it actually could be pretty cool.
Just trying to figure out placement. I think this is pretty awesome as is, but I think 2 more pieces to go along to just, you know, fill it in a little more. So I'm thinking something like that, and then we'll have another one that's doing the same thing parallel down there. What do you have here?
That's the light.
Yes.
That's it.
Yeah, dude, that's sick.
I think it's gonna look good.
How many lumens is this?
I don't care. Looks good. I'll use my cell phone light if I have to, as long as it looks good. What I have to get now is the bezel. There's a black bezel you can get for it. We could paint it too, but I think it's gonna look really good. The black bezel.
Absolutely. We painted it black.
I think it looks great black. I think even with the V-twin in there, it would look equally as good. But the engine is so big, it wouldn't fit in this cage anyways. Because I think the engine hangs over here. I think you have to step on the engine as your footrest.
Yeah, naturally.
Yeah, get the brake.
What we've been debating is what we'll end up doing for paint scheme. If we'll keep the gloss black and the satin black or matte, and we'll probably make it interchangeable where we'll do a gloss frame and then do satin or flat for the bags, the fender flare and whatnot. Anyways, I'm working on the cardboard on the other side here. Notching tubes to make the symmetry on the other side. All right, so we've got some symmetry going on. Battery trays tacked up in place, and we're working on the left foot's control arm over here. And up top, the top tube up here is getting a little bit more of a build out, because what we ended up doing was motor is offset over towards the right foot to accommodate for where the spline and shaft will meet up with the rear end sprocket. So the motor is coupled a little bit this way in position. The battery is positioned a little bit this way for counterbalance of weight. That's where we're at right meow. To give the case in point of what I'm talking about, here is one of the battery modules put in place. And here, with the 15-degree angle added, you can see how it will just clear where the batteries will be. Also, the other point of contention here, if you will, is breaking down and configuring exactly how the frame will be in fact removable so that you can service the motor, the controller, and the batteries. So one of the things that we've been coming up with is it will have 3 points that it'll be bracketed to. One will be here, one will be here, and one will be down here. And the rest of it will just kind of be like a false front. The way that this scalene triangle will connect over here, it'll just connect visually, but it won't actually connect to it. So more on that later.
It's good, man. This looks fantastic. You did a great job. I didn't know you were such a good grinder. You grind really well. Good for you.
You should see me on the dance floor.
Really?
Well, the goal of this was to try to replicate everything that we could on the other side. Mm-hmm. The only problem was, in doing that, when we had the motor is offset over here, and the batteries were offset over here for weight distribution to have it balanced.
Okay.
When we did that, the design on the other side was pretty flat to the frame. This one couldn't be because we had the battery moved out. So this is a 15-degree angle cut on both of these tubes to kind of build this out so that it could still, if you look at it head on, it's still the same visual aspect.
Yes.
But I mean, you know, it is what it is.
People are going to think and say to themselves, wait a minute, that doesn't make any sense because it's permanent. No.
So this is the solution that we came up with, this tab right here. We're going to have 3 different tabs. 3 of these will be false fronts, and then 3 of them will be the main bracketing points that will anchor the frame to it, so that the frame is removable, so that if we have to access the motor, the battery, the controller, anything is able to be repaired.
You can do that.
Changed, but also we wanted to have a form function of giving this exoskeleton as a safety net that kind of, you know, encloses the battery and the motor.
If you drop the bike, which you will, if you're a Harley owner.
Yeah, most Harley owners drop a bike at least twice in their life.
Because it weighs like 1,000 pounds, and there's no saving it once it starts going down.
Yeah, so we figured let's protect what we have here, and also we can remove it so that we can work on it.
Great, fantastic. This is going to be the main drive system of our electric Harley. And yes, we decided to go with the belt drive. And unfortunately, you know, the sprocket hasn't really fully been worked on yet. So the random person that said we should go to belt drive, thank you again very much.
It hasn't been 15 minutes. It's been now 15 days.
It's been multiple days now. It hasn't been done yet. So thank you for the great suggestion of going to belt drive. A pretty simple setup. We have the motor here.
Which, to remind you, is, again, the 20 kilowatt from Golden.
Yes, thank you very much, Golden. And right here, here's the 20 kilowatt controller from Golden as well. Here we have the contactor. You could have a contactor-less setup, but because we're working with 72 volts, touching those wires together and hearing the zap over and over again really isn't that fun. On this side, we have the throttle here. It's a 3-pin throttle. We have a very basic setup going here, and unfortunately, we don't have an official key. We just jump the 2 wires together.
You know.
Yeah, you know, it's just what things do.
And we're only running it to one 72-volt battery right now.
Yes, exactly. This is a very, very basic setup just to see if the motor works, which it should, right? Should work. First thing you do, we jump these 2 wires. These are the key wires. After you jump these 2 wires together, you should hear a click from the contactor. What the contactor does, it completes this high voltage circuit. So let's see what happens. One there. One on this side. The contactor click, now the circuit's energized. So now high voltage is going through the controller right now. We have the red power light, it's not flashing. It's not giving us any error messages. So on this, we have error messages. Depending on how many flashes it has, it'll tell you what error it corresponds to. It goes from 2 to 32. We have various errors like the accelerator defects, controller overvoltage, and controller overcurrent, as well as DC contactor error. So if there's an issue with the contactor, it'll also give you a corresponding number of flashing lights to tell you where the issue lies. So it's actually really, really easy to troubleshoot. And on this side, we have the programming cable. This cable, in order to utilize this properly and program the controller, we have to have a Windows computer. And we don't have one. We use Macs, which is a superior machine.
Right. We could run Windows on the Mac.
Yeah, we could do that. Yeah. But then why would you run an inferior operating system? So anyways, but once we get that going, we're actually going to take a look into the controller itself and adjust settings like throttle input, regen, and also the max RPM for the motor as well. You control how high the motor spins, because this is for different applications. It could be for automotive applications, or it could be for industrial applications where you have like levers and pulleys going, like a belt system, for example, a conveyor belt. On this side, now that we know everything's connected, there's no error lights on the controller. Technically, when we turn this throttle, that shaft should move. What do you think?
And keep in mind, that's all from one single battery.
But everything is really simple to set up. There's wires here, they're already labeled for accelerator. This is for the Hall sensor that goes to the motor, that controls the motor. And on this side, we have various things like we have brake, also cruise control as well. Who wouldn't want cruise control? But we're not gonna use any of those things for that. For the old Harley that this system replaces, it actually had a throttle cable. It had twin cables, one going to the motor itself and the second cable going to the cruise control box. It had a literal box that a cable went into. When you crank the throttle, that's what does the cruise control. So it's an old antiquated system, and now everything's all electronic. It's literally a 2-wire system to maintain whatever speed you want. So now that we know this works, we should probably start the process of putting it all in the bike. Because once we do that, we have to make sure that the motor is straight and it lines up directly in correspondence with the rear wheel and sprocket. What we're gonna have on this side, we're gonna have the motor here as well as the sprocket on top of the shaft. What we have to do when we put the motor in, we have to make sure that this sprocket and shaft lines up with the rear wheel and sprocket. What we do for that, we take the belt that we split in half conveniently. It might seem like it's crazy. Well, we had to do it to get it off. I mean, unless we take the swing arm off, it's a lot harder to do.
Yeah.
So this also helps us with belt measurement too.
Right.
We don't have to take the swing arm off to actually loop this around the front sprocket as well as the rear sprocket and see how much is left for size. So for like an inch off or like an inch and a half off, we can order the corresponding belt. That's how we cut it. All right, so now Steve's gonna show you the easy and simple process of removing the side cage to access the motor and batteries.
Right, so there's 6 points of contact, only 3 of them actually mount. The other ones are false fronts. So they're all on the same massive Allen here. There's one, there's another one up here. And there's this third one down here.
Finger tight, I love it.
Well,
for easy side of the road repairs.
Yeah,
I love it.
We'll never tighten it up.
Unlike an actual Harley.
Yeah.
Right.
Well, usually a Harley drops at least 2 or 3 bolts every time you take it out. So
right.
We'll just put a bunch more bolts in there to fall out.
What we're gonna do is, because this is a living and breathing organism, the oil that's currently in the frame,
yes,
once that's bolted to this, oil will flow through these pipes as well. Which
yeah, absolutely.
Kind of
yeah, we'll add more just for effect.
The second you do that, right.
But
once it's in there, you tighten it down, oil just flows through it. Really cool, actually. Thank you, Harley.
Incredible.
Awesome idea.
Nature is just beautiful.
Isn't
really
it?
is.
One thing I want to talk about was the paint job that we're doing on the bike. We have a few more touch-ups to do on this tank. There's a couple blotchy areas. We want to do another sanding of it and give it a second coat. But what I've been working on are the actual side covers. There's a couple scratches from a previous paint job that was on here before. This bike actually used to be red. This one came out a lot better, but I'm painting these a nice satin black to kind of go with the theme of the bike. I'm actually going to end up painting these saddlebags as well.
Yep. The night is dark and full of terrors.
Seriously, this came out really good. And I think the best part of this, I think we're going to have to keep it, Steven. The belt. The belt is what's holding this entire bike together.
Yeah.
But no.
You love to see it. Where's your belt? Oh, it's right here.
It's right here.
Yeah.
So the tolerances that were welded on this are so tight that you could barely get a sheet of paper in between the battery and the frame. And we did that for a couple of reasons. We did it for rigidity. We didn't really want the batteries to be sloshed around in there. Definitely not at all. It really helps keeping things in place. It also helped us from not having to form a top bracket to match the bottom one. Once we put one on top, it runs the risk of touching the frame and also touching the tank. But this strap actually works really well. What we want to work on next is finding a way to hide this goo, this waterproofing goo. Okay, so now that we have a final idea of what the bike is going to look like, what I want to do is focus on the electronic integration. Obviously, we have a lot of open spots here because the same gauges that were on an ICE engine are no longer needed for this electric motor. For example, we had oil here, we had air pressure, battery voltage for the 12-volt battery as well, which we no longer need. Since there's 4 open slots there, and there's actually 4 individual batteries, what I was thinking was putting 4 individual battery monitors for each battery, so we could tell if one battery is sagging a little bit lower than the others. These are original gauges right here. That one was air. This one is volts for the 12-volt battery. But look at this. This is going to be the new gauge for each individual battery. And this one actually goes up to 72 volts as well, which these batteries do. What I'm going to do is put these 4 pods in, secure them in, just to see what they look like. Again, really easy to install. There's individual grooves that this back cover just snaps onto, and that's what holds it in place against this backing plate. Now we have to put the radio back in. We're going to put an aftermarket upgraded head unit in, and now I have to figure out what gauge to put over here. But so far, this front end's coming together pretty nicely. Those look right at home there, all black faces. They look really good. The second thing I want to focus on is this RPM gauge. I really wish I could think of a different solution for this. Maybe convert this RPM to get the signal off the motor, but I'm not sure if I could do that. But any suggestions on what gauge to replace this one, I'm all ears and open for it. The second most important thing, and arguably the most important thing on this bike, is going to be this right here. This is the equivalent of an alternator. It's called the DC to DC converter. It's just one I picked up off Amazon for maybe like 20 bucks or so. But what this does is this actually takes the voltage from the 72-volt batteries and turns it into 12 volts to run the accessories on the bike. So the original 12-volt battery was right here on this, and this is going to effectively replace the 12-volt battery. I want to have it in an area that's going to actually get a lot of airflow, because this is going to get very, very hot doing all that conversion. And I actually just put it exactly where these terminals were for the old battery. And then after that, all the accessories will be able to light up. What I'll do is I'll have it so it's switched on, and when this is switched, you'll get the voltages of each battery on it. Okay, so we're getting to the point where after we wire up these electronics, we're gonna have this thing roll down the road for the first time. So stay tuned for that.